So last lesson we have talked about like the hybrid function is given different rules and then with different domains. Like say for this one I have cut the real number x-axis into three sections. One section is when x less than -3. One section is in between -3 to 3 and the other section is greater than 3. And as I said, the domain will not overlap. Okay, so the domain will not overlap. So for example, if I take -3 in the middle one, I won't take it in the first one. So to make sure it becomes a function, when subbing one x value, you only get one y value because it's called a hybrid function. It's not like a many to many or one to many relation. So but we only talked about one situation last time. Like for this graph, look at this graph. At the point x equals to -3. Okay, at x equals to -3, there's a jump on the graph. Like for example, the left-hand side graph got -3, 0, but that's an open circle. But if you think about the red function, the middle one, when I actually take -3, the y value is -3. There's a jump, so the graph is not connected. And someone asked me yesterday, like, can they connect it? The answer is yes. If we think about a really simple function here, if fx equals to x plus 1, when x is greater than, let's say, 2, and then, um, so the other one, I will take x smaller or equals to 2. So if I have another function is minus 2x plus, I want 3, so 7. Okay, so let's think about this function here. So it's two linear functions. It's easy to sketch, but the domain is greater than 2 and smaller equals to 2. Let's see what will happen in this graph. So if I think about the first one, I'll just roughly sketch it. So if I just think about 1 and 2, think this point 2. So it's the endpoints, okay, for both graphs. It's the endpoints for both graphs. One graph gets start from this point and one graph finish at this point. So as I said, even though it's greater than 2, I can't take 2. You need to sub that in to see where is that open circle. So if I think about this one, when x equals to 2, y equals to x plus 1, and y equals to 2 plus 1, y equals to 3. So 2, 3 will be an open circle on the first graph. So if I go 1, 2, 3. So this is the point, 2, 3. Okay, this graph will exist on the right-hand side of the function of this of 2. So I will set another point in, which is more than 2 to find another point on linear function. So I will say when x equals to 3, just take the easy one. When x equals to 3, x plus 1 equals to 4. Okay, 3, 4 is the point on this graph. So 3, 4 is here. Okay, 3, 4. So 2, 3 is still on x plus 1, but with domain restrictions, that becomes an open circle. So we connect those 2 points because you know it's a linear. So I can connect those 2 points, and that's my linear for the right-hand side. But if you think about the left-hand side function, smaller equals to 2. So smaller equals to 2. So if I sub 2, let's say I'll sub when x equals to 2, because that's the end point. So when I think I shouldn't use this space. I'll go for it here. So when x equals to 3, mine equals to 2, minus 2x plus 7 equals to minus 4 plus 7 equals to 3. So I have the same point as the left-hand side function. So, but this one is an open circle. This one is a closed circle. So the open circle and closed circle, they both are the same point. So what will happen? What do you think will happen? So open circle and the closed circle, they overlap each other. What that will become? it just becomes a closed circle. So the open circle will not exist anymore. So you can't see it anymore because something closed and something open, they overlap each other. They just fill the open circle there. So they just get connected at that point. Gets just connected at that point. When you sub 2, you still sub into the second function. But the point on the graph you can see is just the connecting point at 2, 3. And I can sub another point on the left hand side of the function. So I can sub 0. So 0 is on the left hand side of 2. So I can see y-intercept at 0, 7. So I can see another point 0, 7 here. And I can connect that point. Okay, so all the way there. So all the way there. So this is the shape of this graph. But the thing is, there's no jump. What I want to say, the difference between this graph and the graph we sketched before is there's no jump because the open circle and the closed circle is actually at the same place. Okay, at the same place. So they overlap each other. You won't see an open circle anymore on the graph. They just overlap each other, becomes a closed circle, and join the two functions together. So that will be the shape of this graph. And you won't see x-intercept because there's like it's past their domain, so there's no x-intercept here. Okay, so that's what I want to say for the hybrid function from last class. And just something to clarify because I always have students have this problem. They don't know how to draw the point 2, 3. They draw, well, is that an open circle or closed circle? So it will be a closed circle and it's just drawing the two functions together. Okay, so that's what I want to say for the hybrid function. And we will look at the last exercise for this topic is the inverse function. Okay, inverse function is very, 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 very important. You know, like 100% of the hard question from 2016 to 2018 for VC methods exam is on inverse function. So every year last question is inverse. Okay, so it's really important. All the sets, like, well, the sets I used to write before, like past 3 years, is all on inverse functions. Like I can ask a lot of things. Basically, what I'm saying is you think inverse function is easy, but actually I can create so many things like on inverse function because there are so many things we can talk about. I won't talk about all of it in year 11 because we will learn that again in year 12, but for like extension, like a little bit extension. But just to let you know like how important this topic is, all the questions in the past 3 years is on inverse function. And in 2017, the questions is ridiculous hard. Okay, so it's really hard. So inverse function, they can just change the way they ask you. They can just ask a lot of things. They can ask about area, they can ask about asymptotes, they can ask about the intersections, so many things we can talk about. So just pay attention to this one. I will talk about some important thing in this session and just emphasize something for you to clarify some of your problems. There will be a question on your textbook really hard. Every year student asks me that question as well. So first of all, we need to understand what's the inverse function. So if you think about fx as a machine, so how do you think about what we have done for fx? We put x value in, we get a y value out, right? That's how the machine works. So, well, we do some calculations in between. The calculation can be 2x plus 1. The calculation can be x squared plus 2. Like, it can be different rules inside. But if we just ignore the rule, like what we basically think about is we put x value into fx, I get a y value out. This is my original fx function. So what is an inverse function? So it's doing things backwards. Any value you get for y, for your original function, you take that, put into the f inverse function, like the value of y, you put into the inverse function, you get original x you put in. So let's say in this way, if you put 2 here, get 4 out. Now you take the 2, put into the inverse function, you will get 2 out. Okay, you do reverse. So you put the y value in, you get the x value. But for the original ones, you put the x in, you get a y. And if you take the y, put into the inverse, it should calculate out the x you originally put in for you. Okay, so that's how inverse function works. That's how inverse function works. So that's a really basic understanding of it. So you put the y value, you get x out. So you think about the coordinates. if you think about the coordinates in inverse function, originally if I have a comma b into my fx function, okay, if I have a comma b in fx function, in the inverse function, what I should have is b comma a. Okay, you put y value in, you get the x value out. So like your y becomes your x becomes your y. You can think in that way. Okay, so b comma a will be the inverse function's coordinates. So basically, what we have is a graph like this. So I'll talk about the graph later. So let's talk about the initial conditions first. For inverse function, it's still a function. Okay, so your original function is still a function. Okay, they are functions. So there's a restriction. Only one-to-one function can find inverse. Okay, so I'll rephrase that. Only one-to-one function can have inverse function. Okay, only one-to-one can have inverse. So if we think about the thing we learned, we have one-to-one, many-to-one, one-to-many. You don't need to copy that again. Just showing you like a revision for the 4 things we learned. They all called relation. Okay, these 4 types are relation. And those two, like one-to-one and many-to-one, they are function. Okay, they are function. And only this one can find inverse. Okay, only this one can find inverse. So it's a quarter of that. So those two are there. Not all the functions can find inverse. It's only one-to-one functions can find inverse function. Let's think about why. If you can think about a comma b and b comma a, if you think about that, it's actually we like swap x and y values, right? We swap x and y values. So then the one-to-one, if you swap the one-to-one, it's still a one-to-one. That's still a function. But how about if you swap one-to-many, a many-to-one, that becomes a one-to-many. So that's not a function anymore. Okay, if you swap the one and the m, like it's a one-to-many function relation now. So it's not even a function. So I cannot find inverse function by using many-to-one function. So many-to-one, when you swap it, it becomes one-to-many. It's not a function anymore. So that's why only one-to-one. Think about the one and one, you only swap it, it's still one and one. So that's the only case. I can have original one is a function and the inverse is a function as well. So that's the restriction. Okay, so this thing is really important. When we learn polynomials later, this is still very important. Like so many questions is on this restriction. They ask you how this function can have inverse. The answer is like it must be a one-to-one function, and you need to restrict it to make it one-to-one. Like we'll talk about this type of question later after we finish this exercise. So inverse must be a one-to-one. So what you can see about this? Oh, it's clear here. So f inverse x equals to y. So if f1 equals x, so this is my inverse. So you put y into this function, you get x out. Okay, you put y in, you get x out. So this is the inverse function. So graphically, well, I don't really want to go all the proofs, but graphically is, I'll write it here, fx and f inverse x symmetrical about the line y equals x. So if you graph your fx function, if you want to graph the f inverse as well, you just need to find the symmetrical mirror image by the line y equals to x. Okay, that's graphically what's the meaning. Because if you swap x and y values, okay, if you have 1, 2, that becomes 2, 1. It's symmetrical point about y equals to x. If you have 4, 3, you have 3, 4, that's a symmetrical point about y equals to x. So if you get all the points, swap the x and y. That's basically just reflect by the line y equals x. So that's why the graphical meaning of it is reflection about the line y equals x. Okay, after knowing that, something else we need to see from the 4 points we need to know. A function can have inverse if and only if it's a one-to-one function. Second, the inverse graph is reflect of fx by the line y equals x. Okay, that's the 2 point I write for you at the beginning. Now the third one, fourth one is really helpful. The domain of inverse will become the range of the original one. Remember, you swap x and y value. So domain becomes range, range becomes domain. So you swap x and y. So all the group of the first element becomes the second element, that's the range. And all the second element becomes the first element, that's the domain. So domain and range swap for original and inverse. So if you know the domain and range for your original function, you will know the domain and range for your inverse function. Now, very important. I don't know whether you have learned this before or if you already know this. But if you don't know that, great, because you can learn it now. If you already know it, maybe following my method because it's actually a safe method. I won't say it's a better method, but I can make sure you definitely get it right. So anytime I ask you to find the root for inverse function, you need to follow 6 steps. Okay, you need to follow, well, they're not long steps, like you need to follow 6 steps. The first steps is you need to state the domain of f. Okay, so give your original function, you state it. So you will say dom of f is what? Okay, that's your first step. List it, like state it. And the second thing is you want to state what's your range of the original function. So if you know the domain, you can sketch the graph and you can find the range. So the second step is find the range of the original function. Second step. Third step is to swap x and y in the root. So if you have fx equals to minus 2 square root x plus 1 minus 4. If you have a rule like that, is this a one-to-one function? What kind of function is this? Yeah, square root has an endpoint. Square root, so it's a square root. So it's a one-to-one function because square root looks like this, or this is all one-to-one function. So it's one-to-one function. So the first thing, the third step is to swap the x and y. So fx is actually y. Okay, remember fx is y. Just treat fx as y. So I swap x and y value. So I'll do that. Okay, that's the third step. So think about what actually has been done for inverse. Is the xy value has been swapped. So you just do that. So swap x and y value. Step number 4 is rearrange to make y to be the subject. We never have function with x to be the subject, so we always have y equals to something. So I will rearrange it to make y to be the subject. So in this case, I will have x plus 4 over 2, plus 4 over negative 2. It's just an example. And I'll square both sides to have y plus 1 and y equals to f4x over 4 minus 1. Oh, you don't really need to copy all this now because we'll do examples later. But as I'm just showing you what we need to do for the fourth step, we just need to rearrange it to make y to be the subject. Maybe note this down. After you find out the y in the step, change it to f inverse x. Because all the question will ask you to find the rule for f inverse x, you can't make y to be the subject. You need to give your answer as f inverse x equals to what? Not y. They are exactly the same thing, but you just need to change the name of it. So f inverse x is that function. Okay, because I don't want to use f inverse to do the rearranging, like it's very tedious, I will just use y to instead of f inverse x through my calculation. Then I change it in the last step, so that's f inverse x. So f inverse x is that. The last 2 steps, you may think it's not necessary, but it's very important. Okay, you may think it's not necessary, but it's very important. What's the new function I get? What's the new function? I know, like the name of the function, like the type of the function. Parabola, right? What it looks like? like something like that, right? What's my square root looks like? Just one of them. Well, they can't become inverse, like it's too much, right? Like my new graph is too much. So there's domain restrictions. So I can only take half of it. Okay, I can only take half of it. So that's why the last two steps is very important. The graph is not right because like quadratic and square root, they can't become inverse. If you reflect a single line, that won't have two lines for you. So what I have to do is restrict the domain. But it's very easy to restrict it if you already done step number one. So state the domain of F inverse. So say zone of F inverse is what? But that's the same as the range of F. So which means it's the same as step two. You already get this answer in step two. You don't need to do anything, you just need to state it. Okay, this is my domain of F inverse, and you can find the answer in step two. Step number 6 is talking about the range of F inverse, and that equals to the domain of F. That you can find this answer from step number 1. Okay, so we stated at the beginning. This step is not always useful. Sometimes you don't really need it. But this step is, well, I hope you can write this down. Help you to decide whether take the sign plus or minus. Okay. Go back to check step number 4. I will show you when we need it, but like write down this and it will make sense to you after we do our exercise. So that's to help you to make decisions to choose the sign plus or minus from step number 4. Okay, so in some cases it's very useful, and this is the only place you can decide it. Well, maybe not only, I won't say only. That's like a really helpful step to make you to select the right sign. Okay. I won't talk too much about it, like because they are all series. I don't want to talk series for too long. If you can go to example 1. How many examples I have? Okay, there's a lot of examples because you can see how important the inverse function is. Okay, example 1, find the inverse function for this. This is still a function, right? Like it's only 4 points, but it's still a function. I can plot it. I can plot, and it's 1 to 1. 1, 2, 3, 4, 5, 6, 7, 8. It's 1 to 1. It's a couple of points, 4 points on linear. Y equals to x plus 1. So it is 1 to 1. What's the inverse function of this? There's no x and y. What's the inverse function of this? Yeah, correct. You just swap the x and y values. Okay, so nothing difficult. If the points already list out for you, you just swap the x and y values, and that's the inverse. Because inverse is the reflection in the line y equals to x, and x, y values will reflect in that way. So what's the domain of the, okay, so let's say this is the function f. This is the function f inverse. So the domain of the function f equals to the range. You can see that equals to the range of f inverse. And that equals to, how can I write the domain for this question? 1, 3, 5, 7, and have curly brackets. Good. There must be curly brackets. It's not from 1 to 7. So 1, 3, 5, 7, 4 points. You use curly bracket. The range of original is the domain of the inverse. It doesn't really matter. So the set not necessarily in order. Like I prefer that in order because it's better for you and me, like both of us. But like set is basically a collection of So range is 2, 4, 6, 8. Okay, let's look at a real question now. Okay, let's do it. I have so much things to talk about. Just listen, please. Find the inverse function f inverse x of this function fx equals to 2x minus 3. Okay, the first thing I want to do is to sketch this graph on your notes, please. Well, it's a linear graph. It should take you 2 seconds to sketch it. Where's the y-intercept? -3. And where is the x-intercept? 3. X-intercept. Anyone can tell me the x-intercept? Sorry? 3 on 2. Thank you. So it's 1.5, which is here. That's fine. Just want to make it accurate. Oh, I have the 2. Oh. Okay. Thank you. Okay. Yep. Good. That works. Okay. Okay. Good. Thank you. So I will have 3 over 2 comma 0 and 0 comma -3. Okay, this is my linear graph. All right, I want to find the inverse function. So I will use the 6 steps I was talking about before. Okay, in this question, I'll let you know, like you think I'm very silly to use that 6 steps because it's easy. But for the next exercise, you can see it's very important to use the steps. So get used to use the steps because you can make sure you get the correct answer. So the first step, I will just talk about steps with you. First step is the domain of the original function. So what's the domain of the original function? All real numbers. Second, what's the range of this function? All real numbers. What's step number 3? Swap x and y. So x equals to 2y minus 3. What's step number 4? Make y to be the subject. Thank you. Y equals to x plus 3 over 2. And y equals to half x plus 3 over 2. And make sure you remember, well, maybe not that step. When you write your final answers, that should be f inverse x, not y. Okay, so that indicates f inverse. They ask you to find the rule for f inverse, so your answer must be f inverse. What's step number 5? Yeah, I have to know this. Yeah, domain of f inverse is range of f. So look back for step number 2, that's real. And step number 6, well, I think you will say it's silly because 5 and 6 is useless. You know that's a linear, it should be domain of R. But like when there's restrictions, that's a different story. So you better have the habit writing it down. Okay, so range of f inverse is the domain of f. Back to step number 1, that's R. Okay, can you write f inverse in function notation, please? Okay, remember what's function notation? The name is f inverse such that such that R to R, domains are mapping to codomain of R, comma. Well, sometimes they will, the inverse sign must be there because you are finding the rule for F inverse, but not always you need to write into function notation. It depends on whether the question asks you to do that or not. So that's a half x plus 3 over 2. So I'll extend this longer. You know what? I'm going to draw the line y equals to x. You know where's y equals to x, right? So I'll draw that. Okay, anyone know why I draw the line y equals to x? That's the reflection. Your graph should looks like a reflection in this line, right? So now I will sketch my f inverse function. A half x plus 3 over 2. What's your y intersection? 3 over 2, right? So that's 1.5. Oh, no, sorry. I sketched the graph in the wrong place. That's 1.5. Sorry, just correct my graph a little bit. So that's my original one. And then 3 over 2, okay, 1.5 is here. Can you see your y-intercept, your x-intercept becomes the y-intercept? Okay, originally I have 2 over 3, 3 over 2, comma 0. Now I have 0, comma 3 over 2. So the x-intercept will become y-intercept. Y-intercept will become x-intercept. So the 0, -3 will becomes -3, 0. Okay, so that will be the point. Okay, this is the line. Well, it's not that accurate, but there's an interesting thing you should notice. Where's the intersection on y equals x? Let's have a think about why the intersection must be on y equals x. They're the same. Why they're the same, then there will be the intersection of fx and f inverse x. Josh? It's not that hard. Just think about dilation. Just think about the slope. Like this line is y equals to x, which means y and x values are the same. Think about that. When you swap, if you have a comma b, the point will go to b comma a, right? Those 2 points won't meet. If you have a comma a, after swap them, what it becomes? A comma a, right? So they're the same point, and they are both the inverse and the fx graph. So that's why they must intersect. Okay, so if you already have 3 comma 3 on your fx, your inverse will contain 3 comma 3 as well. So the intersection will be y equals x, will be that point. So that's why they must intersect. I give you a question to think about. Okay, this is a really hard question, and this is more a year 12 level question. Just think, if fx and f inverse x intersect, the intersection or the intersections will only exist on y equals x. Is that correct? Okay, I will answer this question. and you can do a textbook exercise. You can see similar questions here, I think. But let's think about that. Like I'll talk about this next lesson, like Thursday lesson. But have a think. When fx and f inverse x intersect, the intersection will only exist on the line y equals x. Is that a true statement? Okay, it's important, it's useful for year 12. Think about it. But in this case, we can see that the intersection is actually on the line y equals x, right? And I explain why it will be on the line y equals x. So a comma a inverse is still a comma a, so that must be the intersection. So when I ask you to solve intersections, okay, this only works for part 1 exam. This is just some tips for next year. Okay, so for part 1 exams, when I ask you to solve intersection for fx and f inverse x, actually it's not 2 line intersects, it's 3 line intersects. It's the line fx, f inverse x, and also y equals to x intersects. It's actually this 3 line intersects. It's not only 2 places of intersections, it's 3 like line intersects. So to make it easier to solve, I won't pick fx equals to f inverse x. I'll pick fx equals to y equals to x to solve that. So, well, any 2 intersects will be the intersection because 3 line intersects. So I'll pick those 2 to do my work. Because think about that, this is a linear. Linear is easy to find intersections. But how about if you have a quadratic and you have square root? Ask you to find the intersections between square root and the inverse. It's like quadratic and the square root is very hard. Okay, you have a square and you have square root on the side. It's hard to solve. So in this case, I will pick fx and y equals to x to simultaneously solving for intersections. This is just a quick way to solve it. Nothing wrong if you equalize fx and f inverse x. You still get the same answer. So if you equalize fx and f inverse x, you get the intersection. But I can also equalize fx and x to get the answer because it's the same point. Okay, it's the same point. So in this question, for example, I have 2x minus 3 as my original thing. 2x minus 3 equals to x. Rather than put the other inverse function next to it, I will just equalize to x. So x equals to 3. And you don't need to stop to find y because y equals to x. Your y must be 3 as well. Okay, so I have really quickly solved out the intersection. This point is 3, 3. Okay, this point is 3, 3. So, okay, I have done everything for this question. Find the inverse rule, state the domain and range, and sketch the graph on both sets of x's. And I've shown you intersection as well. And I've shown you it's a reflection about the line y equals to x. The intersection will be on the line y equals to x. I will rephrase in this way. Rather than say the intersects on the line y equals x, I will say when you have point a comma a in your original function, this points must be the intersection. Because if you have 3 and 3 in the original function, 3 and 3 must be a point on the inverse as well, and it must be the intersection between the 2 functions. Okay, I'll skip example 3, that's too easy. I'll do example 4. It's the same type of question. I won't do the easy one. I'll do a harder one, and you can go back to do this easy one by yourself. Let's just look at the time. Okay, 7 minutes is enough for me to finish that. Okay, good. I just have this example to show. Okay, example 4. Let f is minus 4 to 0. Okay, restriction of domain. First of all, it's a quadratic function. Okay, quadratic. Is that quadratic as a one-to-one function or not? No, that's why I have this domain restriction here to make it become a one-to-one function. Okay, to make it become a one-to-one function. So can you draw this graph for me, please? Okay, so with domain restriction -4 to 0 to sketch this graph. Well, the graph will be a positive graph originally, and then you have the point 1, 4 here because that's the turning point. And you want -4 to 0. Think about which part of the graph is that. -4 is somewhere here, and 0 is next to 1. So actually, you want this part of the graph. Yeah? Does that make sense? You want -4 to 0 is that part of the graph. But 0 is an open circle because you're not taking 0. You're taking -4, but you're not taking 0. So what you need to do is to find the coordinates of those 2 points as well. Okay, so what I need to sketch on the Cartesian plane is the red part with correct, so like closed circle or open circle, and I need the coordinates. I need the exact place of it. Okay, that's kind of the shape of this graph. Hope everyone get that. Okay, I'm going to find the inverse. Okay, so what's the domain of your original one? Okay, step number 1 is to state the domain of your original function. What's the domain? -4 to 0, exclusive. Yep. Step number 2 is, well, domain is given normally. And what's the range of that? Kevin, what's the range? Which way? 5 to 29. What kind of circle we have? What kind of bracket we have? Round bracket? Square bracket. Okay, open circle here, we can't reach the level 5. It's open circle there. Step number 3, what we need to do. You should remember the steps now. Yeah, swap y and x. X equals to y minus 1 squared plus 4. Okay, swap y and x. Number 4, make y the subject. Okay, this one's a little bit difficult compared to last time. So y minus 1 squared equals to x minus 4. Y minus 1 equals to what? Root. X squared equals to 4. What x equals to? Plus minus square root of. Yeah, when you square and you want to take the square root, you must remember the plus minus. Okay, if you don't have the plus minus in this question, you definitely can't get the right answer. If you forgot the minus, you definitely can't get the right answer. So you're missing the value. Like you directly get rid of the correct answer. Like, well, I tell you which one's the correct answer now. But you know that you shouldn't have plus minus. I can't do much until the step because that's all I can do. From the equation, I can only get plus or minus. Okay, so I don't know which one I should take. No, like you can do this way. You can do this way, but it takes longer. You can, but it takes longer. There will be a quicker way. So do not worry. Let's keep going with my step. Okay, 2 more minutes. What's the domain of the inverse? What's the domain of the inverse? 5 to 29. Okay, it's the range of the f. And number 6, what's the range of f inverse? Okay, this is the important step now. What's the range of f inverse? It's the step number 1, right? So it's -4 to 0. All right, why the step is important? Go to check with step number 4. Think about the range. Okay, my range is the number less than 0, right? Less than 0. This is plus minus a number and then further add on 1. A square root must be positive. Is that correct? Like square root itself is a positive. If you further add something on 1, that's not true because your range will definitely go bigger than 1. You need range less than 0, like from -4 to 0. So you definitely take the -1. Okay, repeat again. Why you take negative? You need to reduce the value from 1. I don't want 1. I want the value smaller than 1. Okay? The range gives me -4 to 0. I can't take plus. If I take plus, it's definitely more than 1. There's no chance to make it smaller than 0. So I will take the minus. That's why I said if you forgot to take the plus minus, you just directly lose the correct answer. So if you put in function notation, f inverse x, domain is 5, 29, mapping to R, f inverse x is minus square root that plus 1. I hope when I mark your test, no one forgot the plus minus. Even though it's a plus, you still need to write plus minus and then make the discussion why I take the plus, why I take the minus. Okay, so remember the plus minus here and make discussion here. Okay, then choose the correct one you need. From the range. From the range. The range is less than 0. You can't further add something on 1. You must subtract something from 1 to get it below 0. So you must take the minus. Domain of function. Domain step number 5. Oh, no. This is always mapping to R. It's a fixed notation there. I'm not changing that part. In function notation, it won't show you the range. Yeah? And if I quickly sketch it, I will have 0, 5. I will have 5, 0 here now. Okay, so 5, 0 will be an open circle. And I have -4, 29. I will have 29 minus 4 with a closed circle. And you know that's a square root, so the shape is that. It's like that. And what you're glad to see is there's no intersection between them. I don't need to find intersections now. Okay, I basically finished 1, 2, 3 in one step. Okay, so in that 6 steps, I finished that all together. So actually, it doesn't matter how question asks you, you just need to go that 6 steps, and then the answer will just appear. Okay, so that's the end of inverse function. Tomorrow I'll come back to think about that question with you. Like, will the intersection always be on y equals x? Okay, we'll think about that. And I'll give you an example. Next lesson, you can just work on that and work on this page. Okay, question 2 is very important. I may spend a couple of minutes to talk about example 2 tomorrow as well. Okay, so make sure to do example 2 and we'll talk about that and the question we need to think about. All right, so have a break, 5 minutes break. If you need to go, just go.